China dominates the global supply of several critical minerals, and for some years, the country's been restricting exports. Slowly at first, then quickly. In April 2024, the problem came to a head. China all but completely cut off access to several crucial materials in its trade dispute with the United States. At the center of it is a class of minerals called rare earth elements. They're used in a wide array of products, anything from airplanes to electronics, even sports equipment.
It is hitting our defense industry, our semiconductor industry, our automotive industry, our medical industry. There's really no major industry that is being spared the impact of it.
Within 3 weeks of China cutting off access, prices of rare earths shot up 40%. The auto industry was hit especially hard. It's just the latest in a series of supply shortages. Several vehicle plants in Europe shut down. Ford stopped making the Explorer at its Chicago factory in May. Car companies panicked.
You are not going to manufacture a car without rare earths.
They're all over the car.
On June 13th, Beijing signaled a willingness to ease its restrictions. That'll buy some time, but insiders say it's a patch.
We're not out of the woods yet. There is a lot of volatility in the US-China relationship in between tariffs and mineral restrictions. We've seen China ramp up restrictions over 2 years. Rare earths are just the newest one.
The fact is the frequency and severity of these crises is rapidly increased.
So how can the car industry, or any industry, adjust to this new reality? CNBC dove in to find out. First, let's talk about what rare earths even are. They're a class of 17 elements found throughout the Earth's crust, located in many places around the world. They're called rare not because they are rare, rather because the process to separate them from other minerals is very complicated and requires highly specialized equipment. This is what China dominates. Rare earth elements are used in so many things. Among them, wind turbines, wireless technology, microwaves, smartphones, submarines, military aircraft, and yes, cars. They're especially useful for making high-strength, durable magnets, which are essential to motors.
What they do is they make the magnets that are in those motors more resistant to heat and vibration, right? Heat and vibration kind of demagnetize things over time. And there's not many things on Earth better than a car at creating heat and vibration, right? For these vehicles to last a long time and be reliable, you need these materials.
The amount of rare earth elements needed in a vehicle only totals about $50 to $200, which is not that much compared with the cost of other materials. And about 4 pounds of rare earths seems like nothing compared to the 920 pounds found in an F-35. The issue is, if you don't have rare earths, you have no car. Even in a gas car, you need them for all kinds of things, like filtering pollution from exhaust, sensors, small electric motors, even speakers. Hybrids need all that and even more, and EVs need the most. Up until about the mid-1990s, the US led the world in rare earth production. However, there was a turning point when the Clinton administration closed the Bureau of Mines in 1996.
So we began ceding a lot of advantages in everything from uranium to rare earths to other countries.
First among those countries was China. The Asian giant leads the world in refining a host of critical minerals, including rare earths. While it controls most of the world's rare earth mines, where it really dominates is processing, that is, actually separating the elements from each other and other minerals. It has a monopoly on processing heavy rare earths, which are the ones the country has cut off access to.
The real concern, of course, is that this is it's a material that has been artificially concentrated in one region, one country, similarly to semiconductors.
Here's one reason why. In 2010, a Chinese fishing boat crashed into 2 Japanese Coast Guard vessels. Japanese authorities arrested the captain. China cut off Japan's rare earths supply.
So that was the first kind of modern weaponization of these minerals.
China's ongoing trade tensions with other countries only exacerbated the issue. Since 2023, it's increasingly restricted its critical minerals exports. These minerals were used for an array of things, including chip making, defense, and a lot of high-tech products. China even banned the export of rare earth refining equipment, technology, and IP.
We actually didn't even have the technical know-how on how to do it.
There's a concern that they're going to support other countries' military defense, but it's this slow building of leverage. It's not unlimited supply, and China wants to make sure it can hold on to what it needs and what it already has.
Still, the news on full export restrictions announced on April 4th came as a shock. Automakers panicked. Some reported their factories could be idle within a month.
Nobody had any time to react to it, right? I mean, within a matter of weeks, all of the material in the pipeline is out, and nobody could see this coming. There was only so much available at any price.
In June, a report said the Chinese government began granting licenses to some suppliers that serve the Detroit automakers. President Trump said the shortage was over, a done deal.
So right now, it looks like we might be getting some easing in the export controls, so there'll be more licenses, but it's likely going to be a one-off.
The export licenses the Chinese government is issuing expire in 6 months.
So for a lot of automotive firms, the immediate pain point is addressed, but whether this solution holds 6 months, a year and a half from now is totally unclear.
The restrictions have also created a supply bottleneck.
We're expecting those to resume, but they're not going to improve overnight. We're expecting that it's going to take months for the flow of those magnets to really resume, because there are thousands of license applications that are still waiting to be granted.
Dan Hirsch says the auto industry is facing a pattern. The last several decades have been punctuated by periods of intense disruption. They are getting more frequent and more intense, and are increasingly due to shortages of critical parts or materials produced in just one region of the world. In the 2010s, it was a tsunami that hit Japan. A few years ago, it was the COVID-19 pandemic, the chip shortage, and the war in Ukraine. Now, it's rare earths.
A couple years or possibly sooner, it'll be something else that will be in shortage, and we will have not learned our lessons from this. They really do need to take seriously, map their supply chains, really know or have the systems to rapidly collect and understand this information about where things are coming from, who's supplying them.
The challenge is companies guard sourcing information tightly, considering it a trade secret.
And as a result, it's hard to know whether or not you will have a problem whether it's this type of shortage or a volcano goes off or an earthquake or some other type of political disaster.
To reduce reliance on China, one obvious option is to build up supply chains in other countries, including in the US, which once led the world in rare earths production.
The US is actually the second biggest producer of rare earths after China. The difficulty is that we never developed processing capabilities.
When tariffs went into effect in February 2025, companies began stockpiling heavy rare earths. The U.S. government has also given over $400 million to companies with operations here in America, primarily MP Materials and Linus, to build separation capabilities for both light and heavy rare earths, and for a permanent magnet manufacturing facility in Texas. These assets are designed to build the domestic mine-to-magnet supply chain for rare earths here.
The hope is that if China is restricting these minerals, these exports, so much, then maybe the price will get to a point where there's more political incentive and there's more companies and investors that are actually willing to make everything come together more quickly for Western production of these rare earths. But some people are still quite skeptical.
To start, the global average time frame for getting a mine up and running is 18 years, and it's 29 in the US. The business case for such an operation is harder to make when a single country can flood the world market with cheap product.
NdPr oxide is below $60 a kilogram. If it stays at this price point, by 2030, there are only 8 projects in the world outside of China that will break even on direct production costs. So by doing it, by flooding the market, and for them, often backed by the government, they are able to put Western producers who have a fiduciary responsibility to their shareholders out of business.
That said, there are other sources of rare earths around the world: Australia, Vietnam, and Saudi Arabia.
Australia is a really big one. Not only do they have rare earths, they're building their own separation capabilities. The second country we're looking at is Saudi Arabia. One of Saudi Arabia's key advantages are they actually have a big deposit of heavy rare earths, which are much rarer and which we have a lower concentration of here in the United States.
Companies outside China can also try innovating their way out. One path is recycling. There is an abundance of scrap that contains still usable material. In September 2024, the U.S. Department of Defense invested $4.2 million in rare earth salts, a startup that aims to extract the oxides from domestic recycled products, such as fluorescent light bulbs. But extracting materials from something as complex as a smartphone is difficult to do, and once it is done, if it can be done economically, a lot of those materials could be corroded or unusable.
I think the concern is that supply enough to offset the overall shortage? And generally, I think the answer is no.
Another path is to rely less on rare earths altogether. Tesla has reduced its use of rare earths in its EVs by 25%. Toyota has magnet motors with less rare earths content, and supplier ZF has entirely magnet-free ones.
That's the wonder of technology and science is there's lots of different ways to make some of these things.
Minnesota-based Niron is making magnets that use no rare earths. Investors include GM, Stellantis, and Volvo.
We already had very good demand from customers for our technology. After the export controls were put in place by China, we saw a step change in interest both from customers and investors in Niron.
Roundtree says Niron magnets aren't beholden to the same kinds of shortages.
Our magnets are made out of iron and nitrogen, which you can basically mean you can stand up a plant anywhere in the world.
The company is building a plant in Minnesota, scheduled to open sometime between 2026 and 2027. A second large-scale facility is scheduled for 2029.
That 10,000-ton factory will be able to supply, magnets that will build millions of EVs here in North America. And if we need to, we're happy to build plants beyond that.
But in the next 5 years, again, it's going to be one of those situations where we'll have allied supply. We're going to leverage innovation to need less rare earths. And that's, one of America's great strong points.